The Australian Immigration and Border Protection Department processes around 30 million travellers coming in and out of Australia every year. We issue about 5 to 6 million visas per year. To put that into context, any person who is not an Australian citizen must have a visa to go to Australia. A lot of those visas are granted in less than a minute through our electronic travel authority system for those eligible clients that we have. The other visas might take years to consider, but all of them are fundamentally assessed for risk the moment they are lodged with the department. So 4 years ago we were faced with a decision. The decision was really how do we approach this problem, because there was nobody in the world in an immigration service or a border service who had done this. Nobody had tried to use real-time advanced analytics to identify a range of risks, so we had nothing to copy. But there was work in the commercial sector, so banks and insurance companies do this sort of work. Some other agencies do this sort of work, so there were some clues that this thing should be possible. So the big trick is work out how we would approach it, because every immigration service around the world has different data and different sorts of data and different systems pushing the data around the organisation. So again, just because one service develops a solution that suits it, doesn't mean that you can take that solution and just drop it into something else. It has to fit. So what we did is we started doing some testing, and we brought in a lot of research. So I created a file that probably weighs 30 or 40 kilos of almost every conceivable bit of literature that had been written around that, and we read it and we had a look at it. And then we looked at the industry and what was happening, and advanced analytics was a really thriving but a very raw Wild West type of environment. There were lots of things that were happening. So how do you pick the good path from the bad path? So I remember that we decided that, well, we better test our ideas and see what we could do. So we set out to look at a variety of options, and the options really fell into two categories. One category was buy a commercial package that a vendor could provide you with all the possible good faith that it might do the job, but we didn't actually know the language we had to use to explain to a vendor what we wanted from analytics. We had no idea, really. I'd read the books, I'd Googled analytics, we'd worked out what the general world was doing, and there were some really good things happening, but we really couldn't explain it in our terms, and we had no expertise with our data and analytics. We didn't know whether our data was going to be good enough to support a risk analytics approach. So we started testing our ideas. So the choice was, there were commercial vendors who would sell you something, and it would take my $4.5 million like that. It wasn't my money, it was the government's money, the people's money. They would take it almost instantly, and then if it worked, that would be terrific. 50% of most large projects failed to deliver on outcomes. So there was a high risk there that, because we couldn't explain what we really wanted, the vendor might give us something that they thought we might need, and when we tried to switch it on, it wouldn't work. Then there was this really thriving, enthusiastic open source industry evolving, fed by some university sectors doing research. There was the emerging open source in the big data space, Hadoop, which had been kindly released into open source to allow further development. Really dynamic industry, but most of the people around said it's dangerous to go there because it's not scalable. You're dealing with large volumes of data. You have to be up all the time, because if you're not, then the border will stop. The visas won't be granted, and there are probably lots of bugs in there, and there is no support for this. The no support line is of considerable concern to IT departments around the world, because most IT departments are usually just managers of support services. Right? So they don't know how to fix things themselves. They rely on a vendor support base. And when you present to them the option of, let's go open source, and there is no vendor, that presents a challenge for them, and they become quite worried about, the systems breaking down. So we did what most good people do, is we tested. We grabbed a large chunk of our border data. To put that into context, we've been storing electronic data on everybody coming in and out of Australia for well over a decade. So there are hundreds of millions of rows of data waiting just to be asked the question of what do I really mean in this data. So we grabbed a slice of that data, and then we got some friends in and a few experts in the field, and we sat down together and we looked at the data and we looked at what we could do, and we used open source software. It was free, it was widely used, still is widely used in academic research and in some other areas. There are lots of people at universities who learn analytics using R. So there was a fairly good knowledge base. I was fairly convinced that if anything ever broke in the software, that we could get somebody in to fix it fairly quickly and fairly cheaply. We took the movements data, or the travel data, we built some risk models, and the analysts did an outstanding job. Even at the first run of the test system, using a couple of $1,000s worth of equipment and about 6 to 8 weeks of work, we actually demonstrated that we could increase the accuracy of our border targeting by a considerable factor to make it worthwhile. So we had now developed our understanding a bit. We had effectively proven to ourselves that this was a worthwhile path to pursue. There was a cost return or benefits return out of the costs. And we had asked the question, should we now go with a commercial vendor or should we stay with the open source software? The open source software during its whole test time did not fall over once. It had no performance problems. We threw hundreds of millions of records at it, and within seconds it processed those records. And the other advantage was that our analysts developed the models using this software, and we had worked out how to deploy the model on some cheap hardware, basically a 2-core standard desktop PC, and run 40 to 50,000 records past it in a couple of hours, which sort of reflects the inflowing passenger levels that we were expecting. And the machine didn't even break into a sweat. So it was scalable, it was robust, it was accurate. There was our answer. Scalable, robust, accurate. And the price was unbeatable. Compared to spending $4 to $5 million on some licenses of some commercial software that may or may not work, versus we don't have to spend any money on license and maintenance, it created another interesting opportunity for us. The money we could have spent on licenses, I used to bring in some smart people, the analysts who were comfortable in that environment could develop it further. If you buy the commercial software, you need to get the smart people anyway. So I was getting double the bang for the buck. So within 18 months of this lab test, we had deployed across most Australia's international airports a prototype border risk identification system. And within a couple of months of that happening, we started to see the efficiencies being realised. So the whole thing, about 18 months, so conservatively, it was about $1 million worth of expenditure. We now regularly screen the 15 million inbound travellers, 16 million this year, within seconds. We have increased our efficiency at the ports by about 30 to 40%. So we actually, the people we're now speaking to are much more likely to be the people we should be speaking to. And the good thing is, going back to my risk tiering role, we're speaking to a lot less people. So we've actually reduced the number of people, proportionately at least, that we are actually disadvantaging and taking off the line and asking silly questions of, because we don't have to anymore.